Good morning, class. Welcome to the physics online classes for class 11. In the previous classes, we were learning about the chapter circular motion, which were the topic of a motion in plane. What we have seen that whenever a body start moving along the path of a circular track, or we can say that the motion of a particle along a complete circle is known as a circular motion. But it is not necessary that the particle have to move throughout the circle. It can move through the arc of the circle also. So this movement is said to be the circular motion. Okay, and here are the examples which we have seen, that it may be the motion of a planets around the earth or the motion of the satellites around the earth, right? Like earth is moving around the sun, it is also circular motion, and the satellites moving around the earth is also a circular motion. And what we have learned about the linear and the angular acceleration, velocity and displacement. Firstly, we have seen that whenever a body moves along the arc of the circle or the complete circle is said to be circular motion. So let's consider the 2 points A and B. Now whenever a particle moves from A to B, then it's just displacing its position. So here let us write a displacement. Now if we consider that these points movement makes an angle theta with the center. Okay, so if there is the center, then radius should be there. So we can say that whenever a body displaces and makes an angle subtended towards the center, then it is said to be the circular motion. Okay, now if we talk about the displacement of the linear, then whenever a body moves in the straight line, straight path, when it covers the straight path, then it is said to be the linear displacement. Now when the body moves in the circular path, then its motion is said to be the circular motion. So whenever this body displaces and gives an angle theta towards the center, then it is said to be the angular displacement, and it is denoted by the letter theta, which is equals to arc, how much it displaces, along with the radius. So formula can be given as the change in the position, that is from B to A, that is x2 minus x1, because the change in the positions we used to do initial position to the final position. So change in the position can be given as del S upon R, and this is the formula for the angular displacement. Okay, after that we have seen angular velocity. For that, if the body moves along a circular path, then it is moving with the angular velocity, right? So the speed of the body to cover throughout the path of the circle is said to be the velocity. But in the linear we have studied the change in the positions, that is x2 minus x1, can be given as del x. The change in the position with respect to the time is said to be the velocity, and we know in linear velocity is given by the letter v. Okay, and it is equals to del x upon t. And similarly for the angular velocity, here we are using the word omega. It is said as omega, and it is also equals to the displacement upon time. But since it's an angular velocity, so it will be given as the change in the angular displacement with respect to time. So it can be given as angular displacement, that is theta upon time. And what this angular displacement throughout the circle is given as, if it is moving from A to B, then how much angle it is making towards the center is said to be angular displacement. So theta can be given as 2 pi, because r is not considered as an angle subtended by the path of the particle is considered. So it is 2 pi upon t. Here small t and the capital T are different. We have already discussed that t is the time, and if I talk about the capital T, then it is time period, that is the time taken by the body to cover the whole complete circle. Okay, the total time taken by the body to cover the whole circle. Okay, so omega was equals to theta upon t, and which is equals to 2 pi upon t. So this was the formula for the angular velocity. And after that we have seen the relationship between v and omega, and what that relationship was. We know angular displacement theta is equals to s upon r, right? And if we have to find out the velocity, then we have to differentiate both sides with respect to the time t. So here also d by dt of s upon r. Now r could not be differentiated with respect to t, so it will be d theta okay. R is independent of time, so it is 1 by r ds by dt. Now this d theta by dt is the rate of change of angular displacement with respect to time, so it will be changes into angular velocity omega, and it is 1 by r ds by dt. It is a linear displacement with respect to time, so which is given by v. So from here we find that omega is equals to 1 by r into v, or v by r. Okay, so omega equals to v by r. So here v by r can be written as omega, or v can be written as omega r. This is the relationship between linear velocity and the angular velocity. And after that we have seen what the frequency was, right? So any body, if it is moving in a circular motion, then if it is revolving, right, if it is revolving around the center of the circle, now this revolutions, the time taken, it is the time period, time taken by the body to complete the whole revolution around this circular path is given by time period capital T. And if we think that how many number of relations or the number of revolutions have taken by a body to complete around this circle in a 1 second or a unit time, it may be in 1 hour or maybe in 1 second, but we used to take the CGS system as second itself. So the complete number of revolutions taken by the body to complete the path around a circle in 1 second is said to be frequency. So we can say that the number of revolutions per second or the number of vibrations per second, for the wave we may have studied in 9th class also, that number of waves per second, but here that is vibrations per second. So here we are talking about the revolutions. So the number of revolutions per second is given as frequency. It is denoted by the letter nu. It is nu, and it is inversely proportional to time period, because the number of revolutions per unit time. So nu can be written as 1 by t, or if we see t, then it is 1 by nu. So both are inversely proportional to each other, and it is given as frequency of the circular motion. And we have seen the relation that omega was equal to theta upon t, and theta was given by 2 pi by t. And this t, if it is replaced to the numerator, then it can be written as 1 by t is nu. 1 by t was equals to nu. So we can write omega as 2 pi nu. Right? This was the relation which we have studied. So I'm just studying the relations which we have already learnt in the last topic. And after that, now we will be seeing the angular acceleration. Now for the linear acceleration, we know the change in the velocity with respect to time. So it can be given as velocity upon time. Similarly, the angular displacement, angular velocity and the angular acceleration now. So we can say that the rate of the change of the angular displacement with respect to time was the angular velocity, and the rate of the change of the angular velocity with respect to time is given by acceleration, and is denoted by the letter alpha. So alpha is equals to rate of change of omega with respect to time. Okay. So if we have to find the relationship between this alpha and the linear acceleration a, then we know that v was equals to omega r. In the relationship between the angular and the linear velocity, we have seen v is equals to omega r, and if we differentiate with respect to time, that is dv by dt is equals to d by dt of omega r. So what it can be written, dv by dt will be the linear acceleration, so it can be written as a, and again that r is independent of time, so it will be d omega by, and this d omega by dt is angular acceleration, which is given by the letter alpha. So this is the relation given by the acceleration linear and the angular acceleration. So we can say that a is equals to alpha r, since a, r and the alpha are the vector quantities, so we can write it as a is equals to alpha cross r. So this is the relationship between the linear acceleration and the angular acceleration. And the motion chapter, during the straight line, motion in straight line, we have seen these topics, that is velocity, displacement and angular acceleration, linear acceleration. Okay, so we have just related that with the circular motion. So angular displacement, angular velocity and angular acceleration have been key. Similarly, when the body moves, then there should be some force also. So whenever a body moves in the circular motion, so the force is towards the center, the force acts towards the center. This topic will again come in some other chapter also, and there I will be clearing you better. So here the force should always act towards the center, then only we can move inside the circular track in the form of circular motion. So some force is acting towards the center of the circle, and this force is named as centripetal force. That is, the force makes the body to revolve around the circular path. It is known as centripetal force. Okay, and the next thing, the acceleration that is acted upon the body along the radius and towards the center. Like this force is acting towards the center, similarly the acceleration also act towards the center of the circular path, and this is said to be centripetal acceleration. Okay, so centripetal acceleration, whenever a body moves along the circular motion, is acted upon by the acceleration, and it is acted along the radius and towards the center of the circular path. This acceleration is said as centripetal acceleration. Okay, got it? The terms which will be used in this is uniform circular motion. And if we will see the relationship one more, that is the relationship between the acceleration, that is if we have to find the term the centripetal acceleration, then we can write one more relation. And what it is, we know that acceleration is equals to del v upon del t, right? And we have seen that v is equals to omega r, right? V is equals to omega r. So what we can write, v is equals to omega r, and what this omega and v tells us about, v is linear velocity, omega is angular velocity, that is the angular displacement with respect to time. So if we differentiate with respect to time again, so this displacement with respect to time will be velocity, and this velocity upon time will be acceleration. So it can be written as omega r. Okay, so it is, since this r by t is the omega, so two omegas are there, but r is independent of time, so it will be r. And similarly, we know that omega square is v by r, so it will be v square by r square and into r, so 1r and 1r will be cancelled. So here we can write as a is equals to v square by r. So this is the another relation, that is a is equals to omega square r and a is equals to v square by r. So just recall the topics which we have read. So now by seeing what we have read, that is linear velocity, v is the rate of change of linear displacement with respect to time. And when we see about the angular velocity, it is the rate of the change of the angular displacement with respect to time. Angular displacement was given by theta and angular velocity is given by omega. And if you see the relation, this is the relation, that angular velocity omega is given by theta upon t, and velocity is given by the rate of change of linear displacement with respect to time t. And if we talk about the differentiation which we have seen, that how to find out the relationship between v and omega, then it is equals to v is equals to omega r. This is the relationship between the velocity, linear, and the angular. Similarly, this is the relationship between the angular acceleration and the linear one, that is a is equals to alpha cross r. And the second thing, formula, that is rate of change of angular velocity with respect to time. So these are the formulas which will be used in this chapter for the numericals. That is, first, angular displacement theta is equals to s upon r, angular velocity omega is equals to rate of change of angular displacement with respect to time. Similarly, omega is equals to 2 pi by t, and 1 by t was frequency which is given by the letter nu, so it will be 2 pi nu. And the relationship between angular and the linear velocity, that is v is equals to omega r. And centripetal acceleration a was given by omega square r, and linear acceleration a is given by alpha into r. Okay, so these were the relationship which were given by the angular and the linear. So let's see the numericals. So the first question, what it is written here, what is greater, which is greater, the angular velocity of our hand of a watch or the angular velocity of the earth around its own axis? So we know that to find out the angular velocity, we should know the displacement, right? We have to see the displacement also. and we know that is omega is equals to angular displacement upon time. Now theta will always be 2 pi because it is both the motions are circular and they have to move throughout the path, so it will be given as 2 pi. So it will be 2 pi upon time. So the time taken for the body will be, the question was the angular velocity of the hour hand of a watch. And now what this hour hand do? It moves or the complete one revolution throughout the watch. So it will be given by the time taken will be 12 hours. So for the 12 hours, if we take it as seconds, then it will be 12 into 60 into 60. So it is equals to pi upon, if we cancel 2, 6 6 are 36, 36 into 6, 216 and 2 zeros. So what it is? 21600, that is pi upon 21600, and the unit of angular velocity is given by radian per second. Similarly, for the revolution of the earth, since it takes 24 hours to move, so 2 pi upon 24, 2 12s are, again the value is 12 into 60 into 60, 6 is 36 and 36 into 12, so it will be 432. So it can be written as pi upon 43200, and it will also be radian per second. So the next question, calculate the angular speed of flywheel making 420 revolutions per minute. Okay, and we have read that the number of revolutions per second is said to be frequency. So to convert it into revolutions per second, we have to see 1 minute is equals to 60 seconds. So it will be divided by 60. So it will convert it into 7. So we can write it as 7 revolutions per second, and this revolution per second is the unit of frequency. And again it can write as hertz also. So nu is equals to 7 revolutions per second. And here it is written angular speed, so we have to find again omega, but theta is not given here, it is nu, and we know that omega and nu have the relation 2 pi nu, right? 2 pi by t and 1 by t is converted into nu, so it will be 2 pi nu. So 2 into 22 upon 7 into nu, what was the velocity? 7. So both are cancelled, so it is 44 radian per second. So this is the angular velocity when the frequency is given. A body of mass 10 kg revolves in the circle of the diameter 0.40 meter. It is given that the diameter of the circle is 0.40 meter. So radius will be 0.20 meter. The radius is 0.20 meter. And given making 1000 revolutions per minute. So it is moving 1000 revolutions per second will be given as 1000 upon 60. And again it is written here, calculate its linear velocity as well as centripetal acceleration. And we know that the centripetal acceleration is given by a omega square r or v square by r. Okay, so for finding omega, we should have omega also, and acceleration we can find easily because the radius is given. So to find omega, here theta is not given, right? But r is given as well as the nu is given. So using nu formula, that is 2 pi nu, we can find the angular speed. So 2 pi nu, it will be 2 into 22 upon 7 into nu value is 1000 upon 60. So let the values be 2 pi 1000 upon 60. So if it is cancelled, then the value of omega equals to 2 pi nu is given by 100 upon 3. Okay, so it is 100 upon 3 radian per second. So we got omega as 100 pi upon 3. Similarly, we have to find linear velocity, and relationship between linear and angular velocity is given by v is equals to omega r. If omega is 100 pi upon 3 and r is 0.20, that's 20 upon 100. So 100 cancel, it can be given as 20 pi upon 3. Now we have to find out the angular acceleration also. So for angular acceleration, centripetal acceleration, a is equals to omega square r. Now we are having the value of omega also and r also. Omega was given by 100 pi upon 3 and it is given whole square into 20 upon 100. So 100 and 100 will be cancelled. So it is given as 20 into 100. So 2000 upon 3 square, it will be 9, and pi square will be pi square. So the value of centripetal acceleration can be given as 2000 pi square meter per second square, because it is the acceleration. Okay. So here the last question said once in the down that the insect trapped in a circular groove of the radius 12 cm. Again radius is given. Along the groove steadily and complete 7 revolutions in 100 seconds. Okay. So what is the angular speed? That is the omega and v. Then again, is the acceleration vector a constant vector? And if it is, then find its magnitude. What is its linear displacement? So we have to find omega also, a also, and we have to see the value of a. So omega is equals to 2 pi nu. So it is given as 2 pi and nu's value was 7 revolutions by 100 seconds. So on putting the value of 22 upon 7, value of pi, so 7 will be cancelled. So it will be 44 upon 100, which is given as 0.44 radian per second. And again we have to find linear speed. If we are having the angular speed, we can write as v is equals to omega r, which is equals to omega we have now only found 0.44 and value of r, that is radius, was given by 12 centimeters. So on multiplying both, we will be getting linear speed or linear velocity. Similarly, acceleration, that is a is equals to omega square r. Omega's value was 0.44, its square, and its radius is 12. So on multiplying this, we will be getting the value of acceleration. Now, what was the magnitude of acceleration? That is value we have find. Now it is asked that whether the acceleration is a constant vector or not, since the body is moving along the circular track. So the body have to continuously change its acceleration, and we know that the circular motion is a accelerated motion, so it have to change its velocity direction along with the time. So we can say that the acceleration also changes throughout the circular path. So the vector continuously changes, so it is not a constant vector. Okay, so it is not a constant vector. So acceleration is not a constant vector, and magnitude by the finding the value of a by using centripetal acceleration formula. And after the completing 7 revolutions, it is asked that when it started from the initial position, it just come back to the final position is also a. So on completing 1 revolution, it is frequency, but here it is asked whether the linear displacement is there or not. If we ask about linear displacement, whenever the body comes back to initial position after covering the whole path and come back again to the initial, then it is said to be displacement as 0. Linear displacement, so s is equals to 0. Now see the next question. The radius of the earth is given as 1.5 into 10 to the power 11 meter. Okay, so it's asked angular velocity of the earth as well as a linear velocity. So again omega is equals to 2 pi by t or 2 pi nu, but here the nu is not given. So we will use it as 2 into 3.1 for in the time period. We know that whenever the earth move around the sun, it takes 365 days, right? But we know omega, that is given as per second. So it will be 2 into 3.14 or 22 upon 7 upon time period. It is given as 365 days and 1 day 24 hours, and in 1 hour there are 60 minutes, and in 1 hour there are 60 seconds. So the value can be given as 1.99 into 10 to the power 7 radian per second. So this is angular velocity. So to find the linear velocity, again v is equals to omega r, and by putting the value of omega as well as the radius of earth, we will be finding the value of omega. And again asked at how much angle does the earth revolve. So for angle, we will be finding the value of theta, that is equals to 2 pi, and continuously it is moving around the earth. Okay, so let the angle be 2 pi. It is making 2 pi radian along the center, and 365 days. And it is asked that in 2 days how much the angle made. So in 2 days it will be into 2. So on finding the value, we got 0.0344 radian per second. Okay, so you got it how to solve the numericals, that is v, omega, a and r, that is linear and angular acceleration. So thank you class. In the next topic we will be starting the new lesson. In the next session we will be seeing the chapter laws of motion. So thank you.